Howdy students, in this video we are going to discuss something called dimensional analysis, which is what Unit 2 focuses on. To convert from one unit to another, we will use something called dimensional analysis. This method uses equalities, or what we call conversion factors, which most of you are familiar with. That's how we go from one unit to another. So for instance, here's an example. It's not in your notes, so don't worry about it, but if someone gives you 32 quarters, how many dollars do you have? Well, a lot of you would see 32 quarters and immediately you would think, okay, $8, I got $8. But how did you know that? You needed to know for this specific problem a conversion factor from quarters to dollars. And perhaps you know that for every 4 quarters, that equals $1. This is what we call a conversion factor. So if I'm converting, how many inches are there in 4 feet? Well, a lot of you would right away say 48 inches, and you'd be correct. But how did you know this? What did you have to know in order to figure it out? Well, most of you know that in 1 foot, there are 12 inches. That right there is a conversion factor. It can be written as a fraction where the numerator and denominator are equivalent, but have different units. For example, we can use the following conversion factors for changing between inches and feet. And this is important right here. We can write them as fractions. So they can look like this right here, or they can look like these. Now, you'll notice that one of them is reversed. The inches is on top here and inches is on bottom here. What we're going to find is that you can reverse them depending on how you need to convert. So let's convert 24.00 years into weeks. In 24.00, if I'm analyzing this, you'll notice there are 4 sig figs. Perhaps someone used some sort of piece of equipment to measure out that many specific years. All right, so the conversion factor, if you know it, 1 year is 52 weeks. So what I'm going to do is set up what I call the train tracks. Some people may call this the T-table. Some people may call this just conversions. It's up to you, but we're going to show you how to do it. I'm going to start with what I know, which is 24.00 years. And I'm going to put that on top of my train track. Now, I'm going to draw a line, and what I'm going to do is set up this train track. I am splitting the beginning of my problem with the first conversion factor, CF. I'll call it CF. Now, I turned this into a fraction, 1 year over 52 weeks. I can flip it and make it 52 weeks over 1 year, and you have to decide which one to use. We started with years on top, and to cancel our units to go into a brand new unit, we have to make sure they cancel out, top and bottom. So in this case, years cancels, and I'm left with weeks, which is what I wanted. So when we calculate, we get 1,248 weeks. A note on sig figs. There were 4 significant figures in this measurement. We do not use exact numbers for significant figures. This conversion factor uses exact numbers, exact figures. And exact figures do not use significant figures. So we can ignore this conversion factor. So I need 4 in my final answer, which I have. My units are weeks, so I'm done. Some dimensional analysis problems require several steps, like how many seconds are there in 5.0 days. So take a second, let's go ahead and write this down. I'm going to start with 5.0 days on the top, and you'll notice, and I didn't mention this on the last one, there's nothing on the bottom here because we don't have a second unit to convert. In the next video, we'll discuss how to do that. So if I'm going from days to seconds, that's what I wanted here. The first conversion I need to cancel is days. That's why I put days on bottom. The conversion, one day, there's 24 hours. So I canceled out days so that I could go into hours. But I'm not to seconds yet. So I had hours on top now. I need another conversion factor. Hours needs to go on bottom. And the conversion to go from hours to minutes is 1 hour equals 60 minutes. So now hours cancels, and I'm left in minutes. I need one more conversion factor to go from minutes into seconds. The conversion is 1 minute equals 60 seconds. The units will cancel out, and I'm left with seconds, which is what I wanted. These conversions are exact, and so the only number I'm looking at for sig figs would be the first, and there are 2 sig figs. So you need to make sure there are only 2 sig figs rounded in your final answer. So this is correct. One more example here in this video. How many students are in a 10-room building if each classroom contains 25 students? Well, I'm going to start with 10 rooms. The conversion factor was given in the problem. Each room contains 25 students. One room equals 25 students. So this, I pulled the conversion factor from the problem. Nothing on the bottom. It's not a double unit conversion. I need rooms to cancel so that I can go into students. Now, a note on sig figs here. This is an exact number, and this is an exact number. So do I need sig figs in here? No. I don't have to round to a specific number of sig figs. So this is correct. And that's where we're going to stop for today's video.